Hello viewers, today we'll talk about client polling, server push, WebSocket and long polling. We'll see what is client polling, what is WebSocket, what is server push and what is long polling. We'll see the difference between all these four terms and terminology that is we use in everyday. So let's get started. So building a real-time web application is a bit challenging one where we need to consider how we are going to send our data from server to the clients. So we use different technologies, different methods. One of them is client push, client pull, then server push, and long polling. What is client pull? So client in this method, client asks the server for updates as at certain regular intervals. Regular intervals can be in seconds, milliseconds, or hours. Next method is server push, where server is proactively pushing updates to the client, which is the reverse of the client pull. In case of client pull the data, ask server to give data, but in case server push, server gives directly to the client. Next is long polling. Client makes a request to the server, but this is kept open until a useful response is returned. Problem with long polling are empty response, wasting bandwidth and server resources. So here you can see in this diagram, in the in the client polling, client pulls the data from the server. Uh, and in the case of server push, server push the data to the client, so client doesn't need to pull anything. The difference between push and pull technology is that when a client initiates a request from the server, it is called a pull, and when a server sends information to the client within any request, it is called a push. So what is server push technology? So push technology can be referred to as a pushing the information from the server without the client request. It is the opposite of the traditional client server model where a client needs to request a server to push the information. It is used to share the pre-planned information to the client like news, weather updates and other information that clients have not requested, but server push the information based on the client's activities. Push technology is mainly used in business to share time-sensitive information, commodity pricing, new program promotion, or communicate with the clients and employees. Example of push is email, um, push notification on mobile app, etc. So let's see the three things: polling, long polling, and server sent events. So in case of polling, you can see within the fixed or predefined delay, we pull the data. Okay, so as soon as the new data is available, we get the data. In case of long polling, we don't pull the data on a regular interval. We pull the data continuously, and until the data is received, we keep on waiting. So the bandwidth gets wasted in this long pulling. But the most efficient is server send event or server push event, where as soon as the data is available, it will be sent to the client. So client doesn't need to pull on regular interval, or client doesn't need to wait for any data. So bandwidth doesn't get wasted here. So in the case of client polling mechanism, the basic idea is that the client repeatedly pulls or request for a server for the data. The client makes a request and waits for the server to respond within the data. If no data is available, an empty response is returned. Pull technology can be referred to as a communication between the client and the server. It is a traditional way of communication between the client and server. Pull technology is mainly used to drive the content to many applications and devices. Whenever a user browses, it implies a pull technology where a client pulls information from the server. In case of client polling mechanism, the client opens a connection and requests data from the server using regular HTTP methods. The requested web page sends request to the server at regular interval. The server calculates the response and sends it back just like regular HTTP traffic. And the client repeats the above three steps periodically to get the updates from the server. The problem with the client polling mechanism is that the client has to keep on asking from the server for new data. Client doesn't know if the data arrived or not. So many times unnecessary request happens. As a result, a lot of responses are empty, creating HTTP overheads. So there is a basic difference between pull mechanism and push mechanism. In case of pull mechanism, when a client requests this, where a client requests the server for the information, it is called pull technology. And when a server updates the information to the client without waiting for the request from the client, it is called push technology. A user using a web browser and requesting for a web page is pull mechanism. An email is immediately sent from the server to the client without client asking for the email. It is push mechanism. Pull technology is used when advertisers want to reach global audience or build a customer base. Push technology used by online advertisement, chat, email systems, security applications, and RSS feeds, etc. Now let's see long polling mechanism. If the server does not have any data available for the client, instead of sending an empty response, the server holds the request and waits until some data becomes available. Once the data becomes available, a full response is sent to the client. The client then immediately requests information from the server so that the server will almost always have an available waiting request that it can use to deliver data in response to an event. So in case of long polling mechanism, the client makes an initial request using the regular HTTP and then waits for a response. The server delays its response until an update is available or a timeout has occurred. When an update is available, the server sends a full response to the client. The client typically sends a new long polling request either immediately upon receiving a response or after pause to allow an acceptable latency period. Each long poll request has timeout. The client has to reconnect periodically after the connection is closed due to timeouts. There are some drawbacks as well with long polling mechanism. The message ordering and delivery is guaranteed. Message ordering cannot be guaranteed if the same clients open multiple connections to the server. If the client was not able to receive the message, then there will be possible message loss as well. Next drawback is performance and scaling issue, and the third is device support and fallbacks. Now let's see what is WebSocket. WebSocket is a computer communication protocol which provides full duplex communication channel over a single TCP connection. It is different from HTTP but compatible with HTTP. Located at layer 7 in the OSI model, which depends on TCP at layer 4. It works over the port 80 and 443 in case of TLS encrypted and supports HTTP proxies and intermediaries. To achieve compatibility, the WebSocket handshake uses upgrade header to update the protocol to the WebSocket protocol. You can see here, in case of WebSocket, the client sends first to the handshake with the server, and once the handshake happened, after that bidirectional message happens where a client can send data to server and server can send data to the clients. So a typical WebSocket workflow looks like this. A client initiates a WebSocket handshake process by sending a request which also contains upgrade header to switch to WebSocket protocol along with the other information. The server receives a WebSocket handshake request and processes it. If the server can establish the connection and agrees with the client terms, then it sends a response to the client acknowledging the WebSocket handshake request with other information. If the server cannot establish the connection, then it sends a response acknowledging it cannot establish WebSocket connection. Once the client receives a successful WebSocket connection handshake request, WebSocket connection will be opened. Now client and server can start sending data in both directions, allowing real-time communication. The connection will be closed once the server or the client decides to close the connection. So there are some pros and cons as well with WebSocket. So pros of WebSocket is WebSocket keeps a unique connection open while eliminating latency problem that arises with the long polling. WebSocket generally do not use XML HTTP request, and as such headers are not sent every time we need to get information from the server. This in turn reduces the expensive data load being sent to the server. Some of the cons of WebSocket is WebSocket does not automatically recover when connections are terminated. That is something you need to implement yourself and is part of the reason why there are many client side libraries there for WebSocket implementation. Browsers older than 2011 are not able to support WebSocket connection, but this is increasingly less relevant as user has updated browser. Now if we'll see the difference between WebSocket and long polling, so long polling is much more resource intensive on servers, whereas WebSockets have an extremely lightweight footprint on server. Long polling also requires many hops between server and device, and these gateways often have been different ideas of how long a typical connection is allowed to stay open. If it stay open too long, something may kill, maybe even when it was doing something important. So why should we should not build with WebSocket? So WebSocket gives you full duplex asynchronous messaging. In other words, both client and the server can stream messages to each other independently. WebSockets pass through most firewalls without any reconfiguration, and good security models, which origin-based security model is available with WebSockets. In case of server push, server sent events are a one-way communication channel where events flow from server to the clients only. It is not bidirectional. Server sent events allows browser clients to receive a stream of events from a server over an HTTP connection without polling. A client subscribes to a stream from a server and server will send message event stream to the client until the server or the client close the stream. It is up to the server to decide when and what to send the client, for instance as soon as the data changes. So server push looks like this, where we have a client and a server, and once the connection is established, server can send, based on different events which happened on at the server side, server can send the data on different events to the client, and at end it can close the connections. So server push workflow looks like this, where browser clients creates a connection using a event source API with a server endpoints, which is expected to return a stream of events over time. This essentially makes an HTTP request at a given URL. The server receives a regular HTTP request from the client and opens the connection and keeps it open. The server can now send the data as long as it wants, or it can close the connection if there is no data. The client receives each event from the server and processes it. If it receives a close signal from the server, then it closes the connection. The client can also initiate the connection close requests. Now, WebSocket versus server push. WebSocket are undoubtedly more complex and demanding than server send events, and requires a bit of developer input upfront. For this investment, you gain a full duplex TCP connection that is useful for a wider range of application scenarios. For example, WebSockets tend to be preferable for use cases such as multiplayer games or location-based app, whereas server push can technically be used to achieve these. This might cause the domain to get multiplexed. So WebSocket provide bidirectional client-server communication between clients and server. This kind of functionality is vastly applied and appreciated in technologies like real-time polling applications, chat applications, media players, and similar applications. Whereas server push do not provide bidirectional communication. However, there are so many applications where there is no need to send data from the clients. Cases like this and these are updating status, push notification, newsletters, and news feeds. In scenarios like this, server-side events are most appreciated. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.